All right, people. Good morning. Good morning. Happy Saturday. And it looks like we're getting started here. We are on live broadcast, and I am an interactive. We're just getting started here, so we're going to give it a few minutes to get fully set up. Hopefully, allow more people to come in, and prepare for this good tutorial that I got. So let me check a few things. Everybody get settled in. So we checked a few things, and it looks like we are active and live on the broadcast. Welcome. Let me share another screen here. Okay. All right. So give us a minute, 2 minutes, and we are going to start. Go ahead and get your coffee, finish up. You got everything you need? I'm not sure if you need a mask or not, but yeah. Not to force you to take it off or anything. You definitely you feel more comfortable with it on, then by all means. Okay. All right. So, you know what you're here for?
Learn about 3D printing.
To learn about 3D printing? Do you know anything about 3D printing?
Like a little bit like designing, because I went to dance class, but it was a while ago.
Oh. Sorry guys, I'm trying to mute this one camera. It won't let me. No, I'll turn all the volume off. Just not going to be silence. So give me a second here. Check 1, 2. These are headphones.
Maybe you can mute it from like the actual main part, the main camera.
Then I won't be able to hear me. So it is this speaker going back into those microphones and moving background. Cause of feedback. Give me just a second. Troubleshoot could be good. Do you happen to have a set of Bluetooth headphones?
Like AirPods?
Yeah, AirPods?
Yeah.
No, just turn them on if you want.
There.
Yeah. Okay, so you don't have to listen to it on there. I was just trying to get the feedback out.
So if I take them off, then they'll disconnect.
Oh, really?
Yeah. Oh, okay.
go for the next round. All right, and looks like we are back. We're going to see who else is chiming in at the moment.
I'm plugging this thing.
Do what? Okay. It looks like we are good to go. Technical difficulty solved. Everybody comfortable? Got your breakfast? Get your coffee? All right. So good morning. And here we go. We're going to go ahead and open up into the 3D Printing 2020 Intro tutorial, workshop, webinar, seminar, whichever you would like to call it. But we're doing all of that in one, virtual as well as in person. And this will be the beginning of a series. Okay, let me do one more thing, actually, so that we are hitting as many people as possible. I'm going to go ahead and share this. And we will see from there. All right, now, one final time, we are good to go. Again, welcome to the New Age Nerds in collaboration with Interactive 3D and Office Solutions 3D Printing 2020 workshop. We're going to learn everything we can and what we need to know about 3D printing, how to get started, what's the pitfalls, and how to really excel in the industry or in the the hobby that you may have. We're going to go ahead and get started and jump into the presentation. So here, again, we are Interactive 3D Office Systems. I am Sharon Peters, your 3D printing expert and host in today's workshop. And we are here today with Alex Pesic. Say it again. Alex Pesic, a young student wanting to learn and possibly knows already a lot about 3D printing, but maybe learn a little bit more. See if we can today. So I'm excited, he's excited, and we're going to dive into it. So about us, we are going to learn about printing and prototyping, but we are the experts in that field of printing and prototyping. I am Sharon Peters. I am an engineer. I am an inventor, hobbyist, maker, doer of many things at heart. So at the center of all of that is printing and prototyping, meaning getting that idea, physical object out of your head and into a physical thing. That is what we call additive manufacturing, aka 3D printing. Now, there are many other ways to create your ideas, but 3D printing today is the fastest, easiest, most cost-effective methods of producing things now. And that's why I'm so excited about it. And to present that to you guys, my network, to the masses, whoever is interested in 3D printing, we are here to help you out. And that's hobbies, industrial, engineers, anybody who makes physical things can utilize 3D printers. So we have them, we sell them, We repair them. We have services. We lease them. We know and do all things 3D printing. And we are located here in Houston. That's where we are shooting from today. So what are we going to talk about today? That's the update on the 3D printing industry. So the beginnings of it, where did it start with, as well as the evolution of the printers, the machines, the quality, speed, size, materials, everything that goes with the 3D printers, what to do with them, the types, whether it's FDM, SLA, all of these acronyms that you have no idea about. And there are many of them, many ways to 3D print something. There's levels from the lower hobby level, just getting started, all the way up to the professional, high quality, industrial level of 3D printing. Now, when it comes to actually making your print, yes, there's design, and then there's the act of actually printing it. But after you get the print, there's a thing called post-processing. And it's actually, I guess, the second part of 3D printing that you would have to deal with. Meaning there's some unknown parts that you may not know about. If you're just getting into 3D printing, your expectations of what you get may be off. So post-processing, we're going to learn about that. The difficulty within it, the levels of ease from your level versus an expert like me. Who can benefit from it? Many people. What to watch out for, if you're just getting started or been in it for a little bit. What are the pitfalls? You don't want to waste money. Again, I spent $2,500 on my first printer. That same exact printer could be $500 if you do not know what you are looking for and where to get them, which brands to support, which ones are better than others. I am going to give you all of that in a quick jump in the deep end tutorial today. And here we go. Beginning with the update, starting with the background of the 3D printing industry. When did it start? You know when it started? 1986. Did you know that before today? All right. So it began a little bit prior. Let's say there's one guy and his name's not on here, I believe, in which he had an idea for 3D printing, but he never patented it. So that's the first thing, right? So the first person to actually get the patent is Chuck Hall with 3D Systems. So you must be familiar with 3D Systems. I'm sure you are. Well, they are the first actual company for 3D printing. They developed the STL, the stereolithography type of or method of 3D printing. So he started, you can see that machine in that picture here. So Chuck Hall began doing that 86. That's just on the first prototype. It took him from 86 to about 90s, early 90s to actually produce the company that would produce the actual machines and products that will begin the industry and offer it to the masses. During that same time, another guy, Scott Crump with Stratasys. Now 3D Systems and Stratasys, in terms of the 3D printing industry, are the number one and number two juggernauts in the 3D printing industry. As you can see, they started it. So they are the biggest in the industry. They offer the most technology, and they used to be at the lower end for the hobby printers. They have since left that, and they only support the higher end, higher quality industrial printers. But they are the kings of the industry. So you'll see a lot of printers, a lot of support for those two companies, but they are not the only two. There was another company, DTM, but Stratasys bought them out. And going from the 80s to the 90s, as you can see, 3D Systems and Stratasys pretty much owned the industry throughout the 90s. They had the patent on it. There are only two out there that can do that. So they owned the whole industry through the 90s, all the way until the late 90s when they started doing bio printers. So taking those same 3D printer methods done by Chuck Hall and applying them to biology. So you can see a printer there, BioPrint through Lake Forest. It was the first time they were able to literally 3D print flesh or other biological things, like a biological culture in a petri dish. It's living tissue. Can it be used on something? Nobody knows. the industry has developed a whole lot from 1999 to now. And I'll let you know around 2005 to 2009 is where I believe most people noticed a drastic jump in 3D printing. It went from, hey, these 3D printers are $300,000 and you can only get them from a few places, to 2009. Everybody has these little itty bitty printers. They're printing these little things at home in their garage. What happened? Well, if the first patent was filed in 1986, so patents only last for 20 years. Again, in America, patents only last for 20 years, meaning come 2006, Stratasys or 3ds Systems, as well as 2008, the Stratasys initial 3D printing patents, they become public. So now that 3D printing technology, the original technology, it's open to everybody. So that's where a lot of Europeans, Asians were able to create very cheap, off-the-shelf printers to supply the mass market. And that's usually what happens. If you ever, I'm getting a little bit more into the product development. If you ever have an idea, just remember, if it takes 20 years for you to get the original patent, and it takes 20 years to finally flush out all of the kinks and issues with your technology to 20 years later, okay, now you have something good. Well, now at that point, a lot of other competitors are going to come in because your patent is out of date, right? So during 2009, the RepRap, and they call it RepRap, replicator. I don't know what the wrap is for, but it's the replicator system. So I do not remember his name, but there was a guy in Europe who decided to create the very first RepRap, which would be an open source, we say open source, free and open to all who would like it, design for a replicator machine, meaning a 3D printer that has the ability to print and make another 3D printer. And his goal was for a lot of the people who could not afford industrial, expensive 3D printers, well, now they can cheaply 3D print and replicate smaller printers so you could create thousands of them. That is where the Creality printers, I'm not sure if you know the Prusa, the little Prusa printers that you see a lot of the college students putting together, those are RepRaps, and those are free technology. Anybody could make them, you can sell them, and it's pretty good business. And that is where the explosion of 3D printing came about. Good for the little guys, a bit difficult for the big guys because, a lot of the market share became ate up. But since 2009, because we're in 2020 now, there's been further development to where even those free and open source technologies have taken on new life. For example, if you look at Clip and Carbon 3D, this it's not selective laser sintering. We'll go through it on another slide, but another type or another method of 3D printing came about that would allow for very fast 3D printing. So that far right image here, they're able to print things in less than an hour. 4 inches an hour is the newest print speed on one of the 3DS machines that we do have. There's other machines to print huge parts. When it began, you could only print 1 inch in 1986, about that small, and it was, oh my goodness, that's a big thing. Now to print a 1 inch piece is nothing. To print a boat the size of this room, it's pretty impressive with 3D printing, with structural and engineering materials. That is how far 3D printers have come, and they will continue to develop. So there's nothing you can't print. There's not a material you can't print, and there's not a size or shape that you cannot print with 3D printers today. So moving on, what can you do with them? A lot of people, they get their starts in 3D printing. I think a lot of times in school. Have you 3D printed something in school?
For the class I'm taking, we're about to start 3D printing, like 3D print design.
Okay.
So he has like 3D printers in his room.
Okay. You know, what kind does he have?
I forgot what they're called.
So it's in school, so it might be the MakerBots.
Yeah.
The MakerBot Replicator 2. Again, MakerBot is a company. They took the RepRap design and created a whole company behind the printer. But in terms of business, it wasn't actually the printer that got MakerBot its business. Thingiverse. So the website Thingiverse by MakerBot that's set up for people to upload all of their designs all into one central network so that others can download free 3D prints. So now, for example, you wanted to print a toy, or if you wanted to print a tool, a wrench, or something else that's pretty common, well, you don't have to make it yourself. You just go ahead and download it. And that was one of the things that MakerBot got its advances in 3D printing, not necessarily a 3D printer, but everybody, because it's so cheap and readily available, everybody owns the Replicator. More so the Replicator less than any of the higher end machines, right? Quality less, but the cost for certain organizations, especially public schools, it's more cost dependent than quality dependent on the 3D prints. But what can you do with them? As you can see with Alex, projects, engineering projects. Of course, if you're an engineer, mechanical engineer, you need a 3D printer. What can you do with them? Everything within your project, you're going to have to make or fabricate. So a 3D printer is the best because if you need to make something with your project, you can just print it rather than, okay, the conventional methods of starting with a block of material, then having to cut it away or chop, and it becomes messy. You waste a lot of material and you have to go and find stock material to use. Well, 3D printers, you can just make it. Just additive manufacturing, no waste, and the speed is there. The hard part is getting the design, but we'll get to that on another workshop. Today, what can you do with them is making components, mechanical components for your engineering products. If you're a toy maker, making your own toys, jewelry maker, we have dealt with jewelry makers they 3D print that first, let's say, positive for their design. They take that positive and make a mold, and then they mold the actual jewelry, polish it up. It takes away half or at least half of that process of making that first design or that first mold and keeping up the quality. So 3D printing has taken that out. Art, if you're an artist, creating these artistic shapes and experiences are now possible with 3D printers. Before, you could do it by hand. It'll be pretty difficult depending on how good you are. The quality may be off or not, but with the 3D printer, you have the accuracy, the different various materials and colors. You get everything you need within that printer in order to do what you need to do artistically. What else? Fashion designers coming up with new accessories.
That's for your own. I've seen like 3D printing cats.
Medical, very, very much so. Medical and biological casts, as well as implants. So you can 3D print because the materials are good enough now to where they won't be rejected by most people's bodies, to where they can replace a hip or a kneecap or other body parts. Not all body parts, but some sturdy ones. Like you can see there parts of the skull where you have a fracture. They can replace that part. They can match it exactly to whatever's missing and replace that through the 3D printer. Dental implants, they are 3D printed. When one gets braces, I believe braces or implants or caps or veneers, they would scan your mouth, right? 3D print your teeth out so that they have, instead of doing the molds where they used to mold your teeth, now they just scan it. They got the scan in the computer. They can just 3D print the scan and they have your teeth. Now they can replace a tooth or put in the braces to match exactly your teeth or to see how, I guess, the Invisalign, to know if they wanted to change it, they can map that out inside the computer and 3D printers in order to fix all of that. So another way. So these are what, a good 5-6 industries that I've already described that are using 3D printers and printing and design heavily today, and it will only grow in the future. Any questions, comments on that? All good. Okay, so I'm pretty sure there's a lot of other industries out there as well. Automotive industry is printing their parts. Any industry that's manufacturing something is using 3D printers. Now, the types. The 3D printing industry now, it started with 2. Now there are so many different types that it's actually hard to keep up with. And there will be more later. Of course, I even have a new method coming out with. But the main 3 are the FDM, the SLA, and the SLS. And this is where the acronyms are definitely going to come into hand, and what do they mean in terms of you as the user. So first, there are the FDM, fused deposition modeling. That would be the most common today, though it did not start with the FDM. Everything started with the stereolithography, and that was the method used by 3DS in the beginning. Let's say, I think the other methods, we're going to go into this infographic here. And with that infographic, you can see here of all currently different methods, as well as the companies that actually utilize that method for their 3D printers. So starting with the SLA, stereolithography, which is performed like a vat of reactive material and a laser. So a laser, if you look on the screen here, laser, because of its UV light, will cure a UV reactive material. It will solidify, creating a layer of solid material. Once the layer is done, you drop the layer down, put new liquid material on there, and relaser it, and layer by layer, it gets built. Now, that's with a laser and a liquid pool of UV resin is what it's called. Now, you can do that with the laser. You could do that same thing with the DLP projector, which is a digital light, pretty much laser, or CL, continuous digital light processing. So if you notice the difference between old school projectors versus new school laser projectors, because rather than using one line of laser, you can use a whole array of lasers to print even faster. So rather than tracing one line, you can just shine a whole image and you can print layer by layer even faster than the original SLA or SLA. Now, those were the first. That photopolymerization would be the correct scientific technical name for that method. You have a vat of photoreactive resin that's being cured by some type of light, whether it's laser or a projector or a flashlight. FDM, fused deposition modeling. That came out, I believe Stratasys is who were the first ones to come out with that method. I could be wrong. Yeah, Stratasys. So you'll see on here when they list out the companies, the first ones are the people who would incorporate that method into their printers first. So you'll see 3D Systems, this is where it all began. Then Stratasys came out with the FDM soon after, and it stayed just them two who would buy up different technologies through the 90s and the 2000s that you see here, as well as other companies coming into the mix. But FDM takes a cord or a little bead of material and you squeeze it through a little hole. And just like how a hot glue gun, when you glue something, layer by layer, you can build that up. If it's small enough and it sticks to itself, well, layer by layer, you could trace the outline and the insides, and you could build a 3D model layer by layer. And you can see that in a little icon here. Now, those are the two main versions. Pretty much all of the rest of the versions are a variation of these two. Is whether you're extruding out something or shining a light on something or using a laser to solidify something, and all building layer by layer by layer. So there is material jetting. Material jetting is, if you look into the room here, the one back behind Alex is a material jetting. It has a jet of droplets. So instead of having a vat of reactive material, this printer sprays little droplets, layer by layer, and then the little light or laser comes right behind and cures those little droplets. So the little droplets are really, really, really small. So you can get a very high accuracy when you do that. And again, building up layer by layer by layer with small droplets, very fast, very efficient, less materials. You don't have to use a big vat. It's just really droplets, so less waste. So it's going to be cheaper. So that technology is the latest and greatest, one of the latest and greatest that 3ds is using, that's still being used today. Nanoparticle jetting, instead of using a vat, you're using different materials and then melting that material. It could be a wax or some other plastic or some type of metal, in which you just spray on the metal and using something with heat to melt it and fuse it together, as well as drop on demand, same thing. Binder jetting, very similar to the material jetting, is just multiple materials in one. And it's, again, spraying little droplets and they mix together and it's cured together. No need for any, no light to hit. So the binder, like you got two materials that will come together and they create one, almost like the regular epoxy, but very, very small droplets of that epoxy. So it mixes right there and you build up again, layer by layer, layer. Multi-jet fusion would be, again, the material jetting is just multiple jets. Consider this one jet of a whole bunch of droplets. The multi-jet will be multiple jets that are spraying multiple droplets. So faster, more material, bigger parts, more efficiency with that type of printer. And actually, it's the multi-jets that the 2500 has, let alone just one jet. So it has more than one jet. I believe it's a series of a number. It's not just one jet. Selective laser sintering. This is, they say selective lasering. So you have a bed of material and you're using a laser, just like on the SLA, but the laser is going to be very, very hot and melt the material. It's going to fuse that material together because of the hot laser. Rather than just shining a light on it and the UV ray cures it, there's no heat involved. But this one is actually heat, high concentrated heat that's going to melt that material. So that's why they call it sintering. Sintering is the common conventional method of you pour a whole bunch of metal into a mold and you melt it. So that is sintering. SLM, which is selective laser sintering or selective laser melting, same thing. And electron beam melting, instead of using a laser, they use an electron beam. So consider these like laser welding 3D printing. You're laser welding layer by layer in order to create a 3D object. Laser engraving or laser engineering, Netshape. Their one nozzle is spraying either a gel paste of material. A lot of times this is metal, a little paste of metal, or they sprinkle a little bit of metal dust right along the path and then a laser is going to melt that material along that pad, therefore creating a solid line. Again, layer by layer is creating that solid material, again, 3D printing. So if you see, like, these are all different variations to create a 3D object, all of them very similar, but have its differences and its benefits and qualities. Because you can't use a lens sensor or net shape to 3D printing metal, because that involves a whole lot of heat, versus 3D printing a plastic part. You don't want that to have too much heat. You'll melt the whole part. There's differences. There's strength of materials, differences in materials that will require different methods in order to 3D print them. So that would, the others besides lens, EBAM, laminated object manufacturing, that is almost, you put a sheet of paper, you can print out a sheet of paper, like regular printer paper. So let's say I got a stack of, what is a ream of paper? About 500 sheets. So if each one of those, consider 500 layers, and I print that image of that cross section on that piece of paper, and I print out that whole ream of paper, and if I cut it out, I would eventually get that object. So that is another sheet lamination way of 3D printing. So yes, you can 3D print with paper. There are some printers that have that. I know Kodak was one of them, but different core companies here that are listed: Impossible Objects, EnvisionTEC. So this is a very good resource to give you a full scope and range of the type or the methods of 3D printing. And there's more than a dozen here of the whole world of 3D printers. And again, there's more methods coming out now. So let me go back to our presentation. Started with the main three here and went over the whole thing, the whole, I guess, ecosystem of methods. And I don't think I went over the one main method that I find is the latest and greatest. And though they call it still stereolithography, but this version of stereolithography is new, in which they still have the vat of photovoltaic reactive material. As you can see on the screen, it's a vat, and you shine a laser on the bottom, and layer by layer, instead of it being on the top, they're printing it from the bottom, and you can see it layer by layer printing up. So if you've ever seen those printers that are printing it upside down, those are the new stereolithography machines. And it uses way less material, vat, than the other way around. If you did it top down, you would need a big pool. If you do it upside down, all you need is a little layer of material, and you just print from that, right? So less space, less material, faster. And they've invented a new way to where on this method, whenever you cure it, it usually sticks to the glass. Well, now they've invented a way to where they're able to cure the material in the middle of that layer of, or in the middle of the vat of material. So say you got a little puddle, and the puddle sits off about that thick. I'm exaggerating with my hand, but if you ever see, like, there's a thickness to a puddle. So imagine it not sticking to the bottom of the puddle, but it's being created in the middle of the puddle. So it's just kind of materializing in suspension, so it doesn't stick to anything. So it's a rapid growth. So it can print parts 5-10 minutes, less than a half hour, very, very fast. So if you've ever seen the show Westworld, yeah, if you ever, there's an opening scene in which they're pretty much, it's in the future, they're 3D printing bodies. You can see this body being just created in a pool. That technology does exist, and stereolithography is the name of it. And they exaggerate it, put it on a much larger scale, which would be very expensive, but it exists, and it has a name for it. And we are learning about that, or just learned about that today. So that's all of the different methods. Now, there are different methods as well as different levels. I would say quality or professional levels to the 3D printers, starting with the lowest end, what we call the rep wrap or the hobby printers, all the way up to the mass manufacturing and professional quality, industrial quality machinery. On the left here, you can see these are the replicators, the Creality machines, the MakerBots, the Prusas, I'm not sure, I can't think of all the rest of the companies on this lower end. But if you went into your local electronics store that sold 3D printers, they're most likely going to have the hobby level printers. Can they be used? Yes. Are they good enough? Yes. Can you get your job done? So. Depends on the job. If you're a student, you just need one part, one color, pretty simple, then it'll get the job done. But there is a issue with quality. A lot of the printers do not incorporate the whole environmental control of 3D printing. So for example, my experience, when I first got started in 3D printing, it was just a little box. Like you see one of these printers here. I believe this printer is similar to it that I'm pointing at now. It's all open. Now, when it comes to plastic is hydromorphic or hydromorphic. You know what hydromorphic is? Water. It absorbs water. So plastic likes to absorb water, right? So what happens when you heat water up? Steam, right? And steam expands. So if you got a little droplet of water while it's 3D printing, you're going to get these little pops. Pop, 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 pop. Therefore, it's going to throw off the quality of your print. So imagine 3D printing. Houston is very humid, a lot of moisture in the air. And if there's no controlled environment for your printer, you're going to get a very rough print. And it's going to look like crap because every second or so, there's going to be these bubbles popping in your material because of the moisture heating up inside that little bead and it's popping outside that bead. But you can't control that, right? So keeping the material dry, extremely dry, so you can get a good quality print, keeping the environment warm. Down here, it also gets cold. So imagine your 3D printer is open to the environment, a cold environment. The nozzle and the material is very hot, but everything around it is very cold. What happens when you have a hot object in a cold environment? It's going to curl. Heat contracts, right, in a cold environment. So now if you 3D print your product in a cold environment, you're going to see it warps. As it's trying to print, in the middle of a print, you may see it just warp as like it's shivering almost. That's because it doesn't have a controlled environment. All of these printers that you see in which it's just an open box, it's not technically a good printer just off of that. So you can look at that printer and see that it's not going to give me the best print, but it will be good enough. So I could, after that print, either try to, if it warps, try to cut some things off or reprint it. Or if it has a lot of pops on it, I could sand it all off, but it's just more work in the end. I really just want to take my print, take it off, and it be done. That's where a high quality printer comes in. So yes, you can get started with the lower level rep wraps, which range at about $100 that I've seen online to $1,000 or more that I've seen online. Good enough to get started. But if you're looking for quality parts, quality prints, you might need to take a step up. And this is where we get with the MakerBot replicator. So this is one you're familiar with. All the skills that I've dealt with, they have the replicator. The replicator is a good machine. The replicator is the resultant of the lessons learned over a series, at least a decade, 2 decades worth of machines of learning things that went into this machine. So that part that you see there, which looks like a lower housing of an engine, combustion housing, the lower combustion housing of an engine, you can 3D print that. I've seen the quality. It's a very good quality. See the box. It holds that heat in. It doesn't print with as much heat as before. The cartridges are held in its own compartment that keeps the material dry, right? So they took into account a lot of things to control the print as well as the quality of the print, right? So it still has that. If you ever looked at a lower level printer, you're always going to see the layers of that print versus, on these high-end printers that we have here, you can get a mirror finish, a very shiny, smooth finish. Well, that's because the layers are very thin. 1,000 layers versus 100 layers. 100 layers on these machines, you're going to see these little ridges, and you cannot get rid of those little ridges. No matter how much you sand it, if you paint over it, you try to do a vapor, vapor deposition, not modeling, but vapor deposition surface treatment, in which you put that material in a hot vapor that will melt just the outside of the material. Well, even if you did that, you can still see the ridges in it. So you'll never get out the roughness of that print on these lower level printers. They're not made for that. They don't have the resolution to print a high quality, very sharp quality print layer by layer. So again, good enough, high school, college, maybe even some engineering, but not everything. They can only handle but so many materials. You're going to get about ABS, PLA, or a variation of those two, meaning maybe a soft ABS or a soft PLA, a rubbery material, but not too many, if any, engineered materials. For example, have you dealt with carbon fiber material? So some 3D printers, newer ones, like I believe not that one, but on a figure 4, have very high strength carbon fiber materials, meaning as strong as aluminum. So a plastic that's as strong as a metal that can be 3D printed changes everything. Your cars can now be just as strong but lighter, just as fast but lighter. Airplanes just as strong but lighter because of 3D printed parts. Lighter and cheaper. That's the whole goal with these. So can you get that with this level print? No, you're going to have to look at what you're going to make versus the quality that you absolutely need in order to select your printer. So this that I just showed you, the replicator, I believe is like $2,000. So this range, usually from $1,000 to about the $3,000 range. So my favorite was the CubeX, a very large. Again, on these the next level printers, they have a much larger print bed. You're looking like about 9 inches by 9 inches versus the 4 by 5 inches or maybe 6 inch by 6 inch size with the little printers. Now we can take it a step up. Now this is where we get into the beginnings of the industrial printers. Excuse me. The speed at which you print is faster. The quality, and I mean the resolution, mirror finish, very smooth finish, like the plastic finish, glass finish, smoothness within that print, as well as multiple materials, solid, soft, flexible, gummy, different colors, engineered materials, biomedical materials, dental materials. So the range of materials increases, the types of materials increases, the accuracy, the size. On some of them, the size is still about the same as the 6 inch by 6 inch. The figure 4 printer shown here in front that I'm pointing to here. Now that has a print bed of about 4 inches by 3 inches, but it prints taller, meaning with all of your prints. So a good lesson learned is better to print vertical than wide. So again, if you want the resolution, print vertical is better than trying to print it wide. For example, a spoon. You would think a spoon is pretty, because of the curvature of the bowl of the spoon, it would be pretty difficult to print layer by layer, trying to get that bowl and making it look good. If you print it vertically, the machines are better to handle that vertically and still get the curvature than if you were to lay it down. So rule of thumb, vertical is preferred versus horizontal prints. Keep that in mind. But the figure 4 prints vertically, and it prints vertically very fast. That is an SLA printer that I was talking about, in which it prints in the middle of that vat, which makes it very fast. Again, I can't, we will show you at the end of this, but the quality is what we're looking at here. The quality of the print, meaning if I am a upper level engineering firm and I have a customer or a client who needs a very good looking part. For example, new shoes. Somebody has a new shoe coming out and they want it to look exactly like how the designer made it. To every nook and cranny, crosshair, crosshatch, exactly like that. That is where these higher level industrial printers come in which you need accuracy and you need it to look and you need it to function as needed. For example, with the right material, and it can already print the accuracy, and depending on how big your foot is, you could print a whole shoe and wear that shoe from these 3D printers. So I'm thinking in the future, yes, like you'll be able to print anything, from your shoes or the sole of your shoes to, cell phone cases are pretty easy, but in your house, you'll be able to 3D print them, no problem. So something to look forward to. But the cost of these printers, they go up drastically. So we're looking at about $5,000. And I've seen either the Markforged or the what's shown here. There is not the Markforged. The name Leasy. I really can't remember that name. But I'm going to focus on the Figure 4 by 3D Systems. The cost of the 3D Systems is more at the $15,000 to $20,000 range. Now, there are some lower quality, slower machines that you can get for the $5,000 range. And again, there's multiple of them, and their service, their ease of use, the size of the machine will all differ depending on what you need. But what I do know, this Figure 4 here, there is no installation. It's just one box on wheels that you can wheel around to any room, any office, anywhere you need to go. It is one self-contained system, therefore making it so much easier for the end user to just print something and get that print right out the printer and be done. No processing or not much post-processing, not much setup, plug and play. The software is not hard. Everything is just good to go. With these lower end machines, be prepared to be your own engineer or technician to fix your printer. Something will go wrong. They will break. Parts on those break all the time. The nuts and bolts may loosen up and fall out. You will need to know how to fix them if you get the lower end. On the higher end, you're not going to have to worry about that issue. You're paying multiple thousands, so you are going to get some service with that. Now, above these printers, going beyond this, you're not going to get higher quality printers, but you're going to get a higher output. Meaning this Figure 4, going above it, it just becomes into a modular system. So going higher, meaning if you need more than just one Figure 4, well, you could get 4 of them, and now you have a production line of 3D printers for whatever you're trying to manufacture. Let's say, hey, I came up with an idea for a shoe. I did the prototype on the one printer for that shoe. Well, now I could get multiple of that same printer, put them all together, and I'm now a manufacturer. No need for these big, huge machines, CNC cutters, injection mold machines, and another machine just to make that same end part. Now it's just one of the same machine, multiple of them manufacturing multiple of your parts now. So Figure 4 3D Systems, they have a very good new modular system, again called the Figure 4. It's just attached on. Other companies like Stratasys and Carbon, again, they try to do the same thing, in which you just buy a whole bunch of that printer and they could work with each other, just one print by another. And that's how you're doing multiple mass manufacturing. But the quality of each printer doesn't go up. It's just the throughput. You're just buying more machines and more compatibility with those machines to produce more parts than you need. So far, so good on that. Any questions? Good. You know some of these companies?
Yeah.
Yeah. All right. So now, you know about printing. You've selected your 3D printer. Now you know how to get a 3D print. You've printed it out. Now what? So from this picture, you can see on the top picture, a lot of these parts, smooth surfaces in combination with rough surfaces. You can see indentations. All of that was made in the 3D printer. That's how good the resolution is. Now, some printers do not have as much resolution as that, meaning you might have to sand it. You might have to dig out little pieces. You might have to, a part may break while you're trying to do something, right? And you got to put it back together. All of that is called post-processing. Everything you do after you get your part off the print and getting it to the final form of your part. So a lot of printers, if you have a funny shape to it, like a bowl shape, or let's say an upside down triangle or something, well, there's a thing called a support. Let's say if I was printing a F, you can't just 3D print a, let's say a diving board. There's nothing to hold it up. So you need some support material to hold up whatever higher material there's going to be. Now, sometimes that support material is just as tough as the print material. You're going to have to break it away. Sometimes you may have to melt it away if it's a wax. You may have to cut it away if it's the same material, sand it away. At the bottom, there's a Dremel tool, which is a very good tool in which you got to sand it away or cut it away. But either way, you have to get that supporting material, what we call de-supporting your print, getting that support material off in order to get just the part itself. Then you got to clean up the surface. Surface finish, you don't want any, sometimes there's stray hairs sticking off, cut those off. If there's any spikes on the lower end printers, those bubbles that exploded. So when they pop out, the material just ends up like this. So you're gonna have to go and sand that down to get that rough surface to a semi-smooth or smooth-ish type surface. So you're gonna have to polish it, cut it off, clean up the surface, polish it, and if you need to, paint it. Now, 3D printers, not yet, are painting the outside. Yes, you can get different colors of material, but painting within the printer is not a thing yet. So if you need to paint it, that would be part of your post-processing, which takes time and skill. And certain paints do not stick to all 3D printing materials. So if you go to paint, make sure you choose the best paint for your material. For example, I use ABS on my printers. So this will be an ABS. I can't use acrylic paint. I cannot spray paint this. So there is virtually nothing sticks to ABS, come to find out. So just leave it the color it is. Because if you try to paint it, you may make it end up looking worse. Now, for the higher end printers, well, there are paints in it. There are acetone lacquers. There are acrylic paints that do stick to those materials that you can use with the higher end. So it's better. So look into the type of paint or the type of material needed with that paint. So make sure your paint matches with the material. Any questions? No questions. So difficulty. All this stuff sounds pretty technical. You think this is some pretty deep stuff? Yes, they are high-tech equipment, but we're in 2020. So as of right now, this technology is 20, 30, at least 35 years old. So things have become a lot more simple. So the lower end printers, the Prusas, yes, there are little kids building those. You can see in this printer or this picture, the printer, that looks like the first MakerBot. MakerBot Replicator 1 is what it looks like when they first started with the little wooden body. Kids, elementary school kids, put all of that together. Elementary school kids have assembled printers, programmed printers, and printed their parts. These are elementary school kids. So that means all the way up, high school, middle school, college, all the way up to doctorate professionals. They all have the capabilities to learn and utilize 3D printing. So they are not as difficult as they used to be. The simpler machines, the lower level machines are simple enough for kids. The higher level professional machines are simple for kids, but they have a lot more capabilities and a lot more options and features that make them complex, that may go beyond a kid level. But all of these things, just as much as the iPad, they are very easy and simple to use in comparison to what it used to be, as well as in comparison to a lot of other technologies. I think a 3D printer, from what I'm looking at here, might be just as easy as a regular color copier. You put the scan in, you hit the button, and the scan comes out. Simple as that. 3D printers are the same. You put your USB drive in, you select the part you want to print, and you hit print, and it prints. On the lower end printers, you may have to level the bed. You may have to do a little bit more manual work in order for the printer to do what it's supposed to. But again, that's because you have a lower end printer. On a higher end printer, you don't have to worry about that. There's auto bed leveling. There's a lot of technology built into the printers that allows for simpler and easier use. It allows the user to be more hands-off, and the machine itself does all the work. The machine itself cleans the bed. The machine itself levels the bed. The machine itself keeps a track of the quality of the print, or keeps track of the process of the print. So a lot of that is built into the printer, so you don't have to worry about it. So difficulty, these things are simple now. So don't be discouraged on the information. A lot of this technical information I'm giving to you, do not be discouraged. These things are easy enough. Elementary school kids can master them. And again, they are mastering them. Now, the latest and greatest, getting into what pretty much the type of office that we're in now. So we are at Interactive 3D and Office Systems, which is a 3D printer distribution supplier for 3D printers as well as color copiers. So our latest and greatest, what we have here is, again, the figure 4. You can see on the left, the base unit, which is the printer, as well as the controller for that printer. So it's just a computer station, something that somebody could, the user can interface with the screen in order to input or choose different options about the printer so that they can print. So all of that is one system. That's what you would be paying for, plus whatever support services needed. these can be put together. If you want a manufacturing line, say, I don't want to just print one part, I want to print thousands of parts per month. Well, you can simply just add these machines together side by side. And if you put set them up to, hey, I want all of the printers to print this one part all at the same time. Or I could set some of the printers to print this part, some of the printers to print another part, and so on. But either way, a large group up to 23 auxiliary for 24 printers per controller. So each controller can control up to 24 printers, and I believe you can have 23 different controllers set up. So whatever 23 times 24 is, turns out to be a lot of printers. 25 is 20. It's a large number. I don't know. I don't feel like doing math right now. But it's a large number. So 3D printing has entered into and is quickly taking over the mass production, mass manufacturing sector. So no longer is it for prototypes only. If you are a new company with a new idea just starting out in 2020, well, your cost of production just came way down because of these 3D printers. You could fill a whole manufacturing facility with more printers to produce more parts than all the other machines that you would have to get prior to 2010. Again, CNC machines, injection mold machines. So these 3D printers, essentially, we want them to overtake or replace the need for small scale injection molding. So if you're if you're injection molding a few hundred parts, 3D printers can do that for cheaper and faster. If you are injection molding one-offs, 3D printers can do that for you faster and cheaper, right? So that is where these printers or these machines fit in terms of taking over and changing the new industry. So where can we buy these printers? Me, I am the founder of New Age Nerds. So we but I definitely offer because I started in the hobbyist realm. So I built my own 3D printer from a kit. So we offer the hobby lower level printers. You can find them on our website. I have a few Creality printers. All the things that I talked about, possibility of curls, possibility of the popping within that. Yes, these printers will have those issues, but those are lower level printers. They are for the garage inventor. Those printers are for the high school or elementary schools just getting started in 3D printing. You don't need the high quality, nor you don't need the high quantity of parts for a higher level 3D printer. Something small, simple, affordable. That's what we, New Age Nerds, we offer on our website, ranging from cheapest printer is about $300, going all the way up to about a $700 printer. Again, still a smaller 8 by 9 inch bed range, one material, pretty okay quality parts, but nothing like what Interactive 3D and Office Solution offers, which is industrial high-end quality 3D printers. You can see quite a few in the background. We have the 3500 behind me, and behind Alex is the latest and greatest 2500, which is a favorite. Prior to the Figure 4, definitely the printer of choice, still is a printer of choice depending on the materials. So the 2500 is a beast of a machine. It is a multi-jet printer, so it prints fast, it prints accurate, smooth quality prints, very large. I believe it's good 10 inches by 10 inches. I'm not sure about the height. I'll have to give you some specs on that. But of course, we have those printers here. buy them outright or lease them. We offer multiple ways to acquire them, as well as multiple ways to educate you on them. So we have those, and we are here. You can find us at icu3d.com or newagenerds.com. Phone number is here, 281-345-4428. We are open. COVID has not stopped us. We will continue to make and present 3D printing and printers. So with that in mind, that is everything that I have on 3D printers today. If anybody has any questions, I'm going to go back to the StreamYard to see, do we have any questions or do we have interests? You guys want to see some things? I can leave the last few minutes. I'll say we got about another 20 minutes from when I was scheduling to end the live stream. So at the end of this, we are going to talk a little bit about, I'm going to switch cameras here. I'm going to switch cameras here. And I'm going to show you guys. Got Alex here. I'm going to show you guys what a industrial 3D printer looks like. So what we have here is the Project 2500, right? And it is closed at the moment. You're not really going to see the inside anyway. You do not see the inside while it prints. It's going to be a pretty dark print because it is light reactive. You don't want light getting on the inside, so it needs to be protected. If you want, yeah, go ahead. So all we have, Ms. Marcella here, another 3D printer expert and owner.
Thank you for that introduction.
So as she turns on the machine here, I'm going to show all the parts that can be made. And my favorite is always this little guy here. So you can 3D print a little person. Any color. See that inside now? As you see the print bed here. Print right here, pretty simple on the inside, smoothie roller, very simple. I was thinking,
You can show the material cartridges.
material.
2 kilograms of material. This is your build, and this is your support. This is your black support that is semi-melted. When the machine starts, it will melt to a point where it will run through the system. And it stays warm throughout. If the machine is on, it stays on. It stays warm. This is your waste basket. This is where the melted wax goes to the container that is actually recycled. I guess that's
Some curves,
filter.
filters, curve shooting, curve sections.
Okay, battery for it.
The battery, always needed. But all in all, see, very simple printer. All you can do is open up that one section, that's all you have access to. And the print bed, that's all you get. So it's a pretty large print. So way bigger than my hand.
8 inches.
8 inches in depth. So an 8-inch tall part by a good maybe 8.5 by 9 inches. So it's a pretty big part that you can print.
The speed is 1/4 inch an hour.
Quarter inch height.
3 resolutions.
Yeah.
32 microns. We have 32 microns, 29, and we can go down to 16 microns.
Okay. Now that's some good resolution there. So 16 microns. You said you 3D printed this?
Yes, a total 3D printer on the 660 with the color jet printer. That was not painted. Afterwards, it was actually out of the printer in color. On our next presentation, we will have a 660 to run the presentation. So this is your color printer.
Extremely complex parts.
So which one?
Really tail. Tail.
This is actually printed as one piece. You're gonna have to assemble it. It's completely functional once you get it out of the printer. So this is all done. And what it will accomplish is due to the high quality print resolution.
Resolution all in one piece.
This is a very strong material. It's called the armor material. This is printed on the 2500. As you can see, it's got a very nice snap, very strong, the strongest in our out of materials that we can run through the 2500.
And it's strong and it's transparent. And that's never been anything before.
This process is called trap wax. So when you design a body part, you can actually create the design to where you can have the transparency of the acrylic, and then we have wax inside the actual anatomy, and this is called trap wax. It's a process that part of the software that you can use to create this type of anatomy.
Skeletal perception. This one your favorite? Yeah, this is one of mine. It's fun to see the color. So, all three prints.
Looks like a wall there.
Yes.
So that's built. This is out of the figure 4. You can show all these. It's SOS. Yeah. These are with the figure 4, you also have the option to do high temperature parts, which is one of those. This is the high temperature part. And this are your specs on the resolution, the actual time that it took to build, the temperature tolerance, pressure tolerance. With the figure 4, you also have the option to print in a very strong, flexible material. As you can see, this is very fine detail and very flexible. This machine. This is, this one. Another good material is medical grade.
So that's like a tube or a straight tube?
It looks more like a suctioning
Mm.
tube, and it's actually printed out of the 2500 with medical grade material. It's the material is called the M10. So this is very nice for medical devices.
This is professional quality here. You see this on every vehicle. So if we can get the fresh off the show for vehicle quality, then it can match anything to it. All new.
Sure, is that muted?
This one is muted, but the main one on the laptop is not. So it should be able to hear still. Yeah. Should be able to. That's why we'll see on playback. We'll show a few more. Then I'll wrap up. So everything I'm showing here has been printed on the 3D printers.
This goes with a drag in here. This is out of the 2500. And this front piece, you can probably see the resolution here. This is also out of the 2500. Very fine. I'm going to show you the famous wrench, fully functional, out of the print. This is our white material, very strong. This is the shrinkable the material is not in our machine and now it's rubber, not rubber finish. It's about the same. The material is the same. There's no difference. We can run out this machine. What do you run the white Oh, yeah, we can have about. Oh, that's the one, yeah. You can see the flexibility. And this is a functional belt for people who are in the fashion design industry. This is, you can actually wear it. It's too large for me, but you can. If you can still feel the support material, which is a waxy substance.
It works.
You can actually paint this if you wanted to. You can add some spray paint to it and wear it. So, create your own designs, create your own fashion. Your imagination is the limit.
Now springs all in one piece.
Yes, exactly.
All in one piece. Crazy. 3D printers. Never been possible before.
Balance.
All right. So that looks like all we have to show today. Excellent here at Interactive 3D Printing Solutions, Office Solutions, Interactive 3D Printing and Office Solutions. Sharon Peters, Louise Nerds, Marcella,
Balance.
and Alex.
We'll see you next time.
We'll see you here in 2 weeks on the next one.
Yes.
I want to keep it coming. So, to everybody,
See you
please
next
stay
time.
well.
Peace. Hi, coming in. Hey, how are you? Good, thank you.